Hello, we're looking at lesson 1-2, and this is example number 2 in that lesson found on page 150. It's determining whether a relationship is a function. Now, a relationship is the comparison of two numbers regardless. It could be x and y, it could be p and x, it could be whatever. It's just a comparison of two numbers. However, for that relationship to become a function, then the function has to have exactly, for every element in the domain, which is your x values, you've got to have exactly one element in the range. Bottom line is this, to make things really easy for you, is if you're looking at a set of numbers and you're trying to determine whether they are a function or not, the x values cannot repeat, because that would mean that look at the ones right here in the blue. If I look at that right there, notice that 1 is going to 6, 2 is going to 6, 3 is going to 8, 4 is going to 9. Now, it doesn't matter if two things are going to the y value. It's just two things can't be shared with the x value. For instance, look at this one. 6 is being compared or being matched with 1, as well as 6 is being matched with 2. And so because of that, you have 6 kind of repeating itself. 6 is matched with 1, 6 is also matched with 2. So let's take that and apply that to the A and B here. I think it's easier to just remember in the back of your mind. I know that the true definition is that every element in the domain has to correspond with exactly one element of the range. And in A, that's exactly what happens. Notice I have a 1, a 2, a 3, and a 4. There are no repeats in the x value, so therefore A is a function. In contrast to that, if I look at this one, 6 is matched with 1, 6 is matched with 2, then 8, and 9. I hope you can see here that the 6 is being repeated more than once. Therefore, it leaves it to be not a function when that particular thing happens. Okay, let me scroll down a little bit. Erase my marks. So that is kind of the basis of all this. Now look at checkpoint number 2 here. Again, for the same reason, I have a 1, I have a 3, I have a 5, and I have a 5. Since the 5 is repeating, this one is not a function. As opposed to this one, I have 1, 3, 6, and 8. None of the x values are repeating. That means they each have a distinct y value that matches them, so therefore this one is a function. Okay? So it's actually pretty easy to determine whether something is a function or not. I hope this was helpful.